Okay, so today we're going to talk about how we find slopes of lines that are parallel and perpendicular to each other. And this covers the standard AA38, which is to determine whether two lines are parallel given their equation in any form. So first, in order to determine if they're parallel, we're going to have to figure out, given their equations, we're going to have to figure out the slope from that equation, and then look at the slopes and compare them and determine whether or not they're parallel from that. Okay, so for the first thing, we're going to look at two lines that appear to be parallel. Okay, and parallel lines, remember, parallel lines maintain the same distance between the lines always. Right, so if that distance got larger or smaller, we would know at some point that they would intersect, even if they don't intersect on the page that we have them drawn on. But here, these lines appear to be parallel because the distance between them appear to be the same. Okay, so let's take 2 points on the line. Let's call this one L1 and L2. Let's take 2 points on L1 and draw this little triangle here to find the slope. Remember, the slope is rise over run. Okay, and L1 is increasing because the leftmost point is lower than the rightmost point that we chose. Okay, so the line, as you walk from left to right, if you are a person on it going from left to right, you'd be walking uphill, as opposed to a line that looks like that where you'd be walking downhill if you walk from left to right. Another way of thinking about it is as x increases for L1, as the x coordinates increase, the y coordinates also increase. So both L1 and L2 are increasing. So we know their slopes right off the bat. We know their slopes are going to be positive because that's what happens when you have increasing lines. Okay, so the rise here is 1, 2, 3, 4, 5 over the run, which is 1, 2, 3, 4, 5. Okay, so the slope, L1 has a slope of 5 over 5, which is 1. L2, let's do the same thing here. Let's pick out a couple points. So here's a good point, and this looks like a good point here. Okay, so the vertical change is 2 versus the horizontal change, which is also 2. So L2 has a slope of 2 over 2, which also reduces to 1. So their slopes are identical. Okay, and that leads us to principle number 1. If two lines are parallel, then their slopes are equal. All right, if I found the slopes of these two lines here, this one and this one, these lines are decreasing, so their slopes are going to be negative. So from the leftmost point, we go down 1, 2, 3, 4, 5. We go down 5, and to the right 2. And you'll see if I did the same thing with this line right here, again, I'd see this identical. Not only are these triangles similar, they're also congruent. So we go down 5 and over 2. Right? So the slopes of these two lines are equal to each other because they're parallel. We can see that they're parallel visually by looking at the distance between the two lines right here. I actually should have given you that as a premise. So I should give you that L1 is parallel to L2. Okay, so if they're parallel, then their slopes are equal. And this also works the other way around. If their slopes are equal, then they're parallel. And that, intuitively, oops, parallel is spelled wrong. That intuitively makes sense to us because if their slopes were not the same, it would mean that one would be increasing or decreasing faster than the other. And if that happens, then you know that this distance between the lines are not going to be maintained the same way. And if that distance is not maintained, then at some point they intersect. And if at some point they intersect, then they can't be parallel. Okay, so if the distance is maintained, it means that they're both increasing or decreasing at the same rate. Their inclinations are the same, which means that their slopes are the same. Okay, let's investigate two lines that appear to be perpendicular. Now, actually, I'm going to give you that, let's call this L1 and L2. I'm going to give you that L1 is perpendicular to L2. Okay, now let's look at their slopes. Remember, perpendicular means that they meet each other at right angles. So they intersect at right angles. They create right angles when they've intersected. So the slope of one line, let's look at the slope here. Now L1 is decreasing because it's going downhill. As x increases, as the x coordinates increase, the y coordinates also increase. I'm sorry, as the x-coordinates increase, the y-coordinates decrease, so it drops. So this line goes 1, 2, 3, 4, negative 4, and right 1, 2, 3, 4, 5, 6. Okay, so the slope of L1, so I can write it like this, the slope of L1, that might be a little confusing, the slope of line 1 is equal to negative 4 over 6, which is negative 2/3. Okay, now let's investigate the slope of L2. Okay, I have a point here, I have a point here. It's increasing, so I know the slope is going to be positive. So the slope of L2, I know right off the bat that it's positive. Now it's going up 3 and to the right 2. So the slope is 3 over 2. Now let's compare these two numbers, 3 over 2 and negative 2 over 3. Clearly they're not equal, but we can see some pattern here. Okay, 2/3 is the reciprocal of 3/2. Also, negative 2/3 has the opposite sign of positive 1/2. So this leads us to principle number 2. If two lines are perpendicular, their slopes are negative reciprocals of each other. So they're reciprocals, but they also have, by negative I mean opposite reciprocals. Okay, so they have opposite signs to each other. So let's just look at these two lines one more time. Okay, let's call this L1 and L2, and it's given that L1 is perpendicular to L2. Okay, so L1 starts here, we go like this, and it has a rise of 1 and a run of 1, 2, 3, 4, 5, 6, 7, 8. Okay, so the slope of L1 equals 1 over 8. And L2, you can see that not only is L2 decreasing, so if the two lines are perpendicular, it would make sense that one's increasing and one's decreasing. So it would make sense that their slopes have opposite signs. Okay, because if they're both increasing, then they're not going to be perpendicular. Like if they're both increasing like this, eventually maybe they would cross each other, but they're not going to cross each other at 90-degree angles. So L2, where L1 has a run of 8, L2 has a rise of negative 8. So, okay, let's see this. Let's pick this point and this point. That's good. So it would make sense that where L1 has the horizontal change is 8, L2 has a negative vertical change of negative 8. Okay, because they're hitting each other at right angles. So whatever change L1 makes horizontally is the change that L2 makes vertically. Okay, so the vertical change here is negative 8, and the horizontal change is 1. So the slope of L2 is negative 8 over 1, which is negative 8. So if we look at the relationship between 8 and negative 8, 1/8 and negative 8. 8 and 1/8 are reciprocals, and positive and negative are opposites. Okay, so if I give you that the slope, let's say that I give you a slope, let's say that's negative 4, for instance, and I ask you to find the slope of the line that's perpendicular. Okay, well, first I'd have to reciprocate 4. The reciprocal of 4 is 1/4. And then I'd have to take the opposite of negative 4, which is, this one has a negative sign, so the opposite of that sign is positive. So let's put that all together. That should be, the slope of a perpendicular line would be positive 1/4. Okay? Likewise, if I gave you a slope of, let's say, 1/3, to get the slope of the line that's perpendicular, I'd want to reciprocate 1/3 to make 3. And then I want to take the opposite sign of positive 1/3 to make negative 3. Okay? And by the way, it works the other way around. If two lines have negative reciprocal slopes, or opposite reciprocal slopes, then they are perpendicular. Okay, so if I say, okay, here's a line, has a slope of 9, the slope of another line is negative 1/9, I can say, okay, these two lines are perpendicular. Okay, or if I say, oh, here's a slope of one line, it's 10, here's a slope of another line, it's 10, I know those two lines are parallel. Okay, so it goes two ways around. The argument goes two ways around. And so that's the end. So if I give you an equation like y equals 3x plus 1, we're going to get to looking at equations in this form. It's called the slope-intercept form. So this number right here is the slope of the line when you graph it. So if I give you this equation right here and I say, okay, y is equal to 3x plus 2, oops, 3x plus 2, and again, this number is the slope. And if I look at this line right here, that's the slope here, and those two slopes are the same. Those lines, I know that, but even before graphing, I know those lines are parallel. And that was the heart of what we're supposed to, that's the heart of this standard. It says, if you're given the equation, you should be able to determine if they're parallel or not. And likewise, if you're given an equation, you should be able to determine if the lines are perpendicular. Okay, so that's the end of the lesson for today.